Hi, we are the 3D holographic display team for our sponsor Toby Rhymes from Watts.ai, and our mentor is Dr. Newman. We hope our solution can benefit those in education, healthcare, entertainment, and business, and we also see benefits for users that suffer from attention impairments or those suffering from Alzheimer's by using the AI assistant to recall past conversations.
Our proposed solution is a swept volume. It consists of two matrix of LEDs on a motor that's spun really fast that creates the illusion of a 3D object. Our key design elements here are hologram rendering, which is just the visual holograms on the matrix, user interface and data acquisition, which is the sensors and the data captured from the sensors that integrates with the hologram, design decisions, which is the LED panel and the frame, and the trade-offs. The most important trade-off here would be complexity versus time. Now, our project seeks to integrate the human interaction with the hologram. So the touch and gestures would match the touchable vision, and then integration of voice and camera would allow you to feel like the interaction is more direct with the subject.
For our design approach, we decided to use a double-sided LED panel with the Hub 75 interface. With double-sided panels, this allows greater light exposure as the LED panels are spinning within the swept volumetric display. One of those panels will be aligned with the direct center axis of the device. Using Hub 75 interface, this allows RGB color bits to be sent concurrently to both LED panels. And so a Raspberry Pi 4 was chosen to meet real-time requirements to drive voxel data to the LED panels. As for the power requirements, a 250 watt 12 volts power supply is sufficient to power the LED panels, Raspberry Pi's motor with a motor driver, and other sensors. And so here is our block diagram that showcases the power rails to power various devices, a Pi 5 for sensor input and output, a Pi 4 to drive the LED panel, and an RP2350 and RP2040 for sensor input.
We had several problems throughout this project, but a couple design issues to highlight is that running Unity 6 on our Raspberry Pi 5 just proved to be a little bit more difficult than we intended. Additionally, there were a lot of shipping delays, especially with our slip ring that came in pretty late. We found out there were some issues with the architecture using the SPI slave master between the Raspberry Pi 5 and 4 that forced us to use UART. Additionally, some of our prints failed quite often, and we would often change our design while it was printing and then have to just start over with a new print. Additionally, we had to solder by hand a lot of devices onto some protoboards that we weren't originally intending to do. It probably would have been helpful if we had assigned responsibilities in a way that more aptly aligned with our individual strengths, and we could have communicated a lot better both within our team and with the AI team. Additionally, as for the features of our device, the big things to highlight is that we have two panels of RGB LEDs in a 64 by 64 matrix, which is driven by the Raspberry Pi 4, with 100 slices per rotation at somewhere between 12 and 15 FPS. And we have several sensors that are designed for both unique and intuitive user interaction, and several sensors that are responsible for maintaining the hologram itself, including the Hall effect sensor and the IR sensor.
What is this?